Alrighty, you guys, what is up? So today we are going to derive. Derive what you say? We're going to derive the quadratic formula. Woohoo! So deriving any formula uses two things. The two things that it uses are your knowledge about literal equations. We learned that a literal equation is simply just a formula. But how you get or why we use literal equations is we use the inverse operations the same way that you would use to solve to figure out the value of x. That's the same operations that you end up using to then manipulate whatever your literal equation is to create a new one. So that's what we're going to end up doing. We're going to use inverse operations to manipulate a literal equation to get the quadratic formula. So just as a refresher, x is equal to what? Negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is our goal. But we have to start from somewhere. And where we start from, where we're starting from is standard form. Our standard form of a quadratic. Standard form of quadratic is simply ax squared plus bx plus c is equal to 0. So we have to manipulate this. So again, we're going to use inverse operations. So the first thing I'm going to do is subtract c from both sides because that's the simplest. So I get ax plus bx is equal to negative c. Because again, I want to get x all alone on the left-hand side. That's my goal. So when I go ahead and do that, from there, I notice there's really not much more I can do, but what I can do is I can actually try to get rid of that coefficient a, this a right here. And how I'm going to go about doing that is I'm actually going to multiply this whole thing by 1 over a, because remember in the quadratic formula, we have an a on the top and an a on the bottom. You'll see how we'll get the a on the top in a second. But when I do that, the a there cancels, and I end up getting x squared plus b over ax is equal to negative c over a. So I end up getting this guy right here, which is pretty nice. And this is where I start to get a little iffy because I have this coefficient right here, and I'm going to have to play around with him. So specifically, what I'm going to do to this coefficient is I am going to divide it by 2 and raise it to a second power. So what that looks like is we have b over a all over 2, and then the entire thing is going to be squared. And I'm going to add that to both the left-hand side of the equation and the right-hand side of the equation. So I end up getting x squared plus b over ax plus the result of that guy, which is b squared all over 4a squared, which is then is equal to negative c over a. And what you do to one side, you have to do the other. So that's again plus b squared all over 4a squared. So this was the guy, my result, and this is what I added to both sides because inverse operations like a mirror, what you do to one side, you have to do the other. So the reason why I want to do that is because I know I have the ba squared, 4ac, and I need to do something with it. But now I'm going to try to simplify the right-hand side. So we're going to be working on this side right here. And right now, I notice I have 2 different denominators. So what I'm going to do is I'm going to try to get common denominators. So I'm going to do negative c over a, and I'm going to multiply that by what? Well, I'm going to multiply that by 4a, and that is how we get the a up at the top, folks, because you know 4ac. And oh my gosh, look, we also get a 4 up there. Again, the reason being is I'm just simply trying to get common denominators for this 4a squared right here. So when we do that, we end up getting negative 4ac plus b squared all over 4a squared. And then if I were to write out the whole formula again, we end up getting x squared plus b over ax. And again, we have that funky guy on the right, so that was b squared minus 4a squared, which is equal to, now, it's equal to this guy right here. We know that's equal to that guy. But I'm going to use a cute little property and switch these guys around. Why, you may ask? How did it go again? B squared minus 4ac, and holy cannoli, look what we have. B squared minus 4ac. So now I simplified the right side. So now I want to simplify the left side. That is my next goal. I want to try to simplify this guy. So how I'm going to end up simplifying this guy right here is I'm going to just factor this. I'm going to represent this trinomial as a square of a binomial. So basically, I'm just factoring it because that will give me a much more desired number or phrase or expression. So when you end up representing that as a binomial squared or doing the factoring to get that, you end up getting x plus b over 2a all squared. And again, I didn't do any kind of like super crazy math. What I did is I simply just asked myself, given this guy right here, hello, how are you? Given this guy right here, I just rewrote him in another way. Wouldn't necessarily be the way that you would think initially, but we're trying to get to x is equal to negative b plus or minus the square root, and I need to get a square root in somehow. So now the question remains, how do I go ahead and do that? And how we go ahead and do that is purposeful. And that's part of the reason why I want to represent it as a binomial squared, because how do you undo a square? You undo a square by taking the square root. So we end up getting x plus b over 2a is equal to that square root. But we know square root properties given a fraction is that it's the square root on the top and the bottom. So what we end up getting is b squared minus 4ac, which is what we want in the square root already. And then we get 4a squared on the bottom. But both a squared and 4a, and I'll show you what's separated because I'm a nice guy, both of those are perfect squares, which is what I want. Give me a sec to catch up. So this ends up being 4, and then I don't need to put that multiplication sign in there, but I did anyway. So what we end up getting is x plus b over 2a is equal to the square root of b squared minus 4ac all over the square root of 4 is 2. Square root of a squared, a. So we are so close. We are there. I'm so excited. But you might notice something. What's missing from this? Well, do not forget, anytime you take a square root, it is plus or minus. And so technically speaking, we had a plus or minus right here. Plus or minus. If I scrolled up here, plus or minus. That is extremely important because we know it's plus or minus the square root. Now I only have that plus or minus up at the top because I undid the square roots at the bottom right here. So that is super, super, super important. So now the last thing I'm going to do is, well, I want to get x by itself, right? And well, currently right now, x is almost by itself. The only thing that's in the way is this b over 2a. So I'm going to do negative or minus b over 2a minus b over 2a. And that's going to give me x is equal to negative b over 2a plus or minus, and then this guy. So we end up getting the square root of b squared minus 4ac all over 2a. And what did you know? Hey, they have common denominators. So what can we do right here? Well, we can put them all under the same fraction. So negative b plus or minus the square root of b squared minus 4ac all over what, folks? 2a. And lo and behold, we have the quadratic formula. We took standard form of a quadratic and we derived the quadratic formula. That is exactly what we wanted. Yippee. So it's a lot of work, don't get me wrong, especially when you start looking at right here how you can manipulate the b over a when you simplify on the right-hand side to get the 4a, thinking about getting a trinomial and representing it as a binomial squared. You know, it gets to be a little difficult when you're looking at those kind of steps. But at the end of the day, is again, nothing really more than simply using inverse operations, and that's really what we did, or simplifying, or, you know, adding or subtracting equivalent numbers, adding or subtracting, multiplying and dividing by 1. So, you know, it's nothing that we haven't done up to this point, but that is how you take standard form and derive the quadratic formula. So hopefully that made sense. If not, you know how to get in contact with me. Peace out, Girl Scouts.